Okay. Now I can say it. Test 2 is next Monday in class. Okay. It covers chapters 2 and 4. You may or may not recall, I have one more example that I wanted to do in section 4.6. And then that'll do it for this section and this whole chapter. So what I was thinking of doing in terms of the order of things today is I was thinking of first working through that one other example of Newton's law of heating and cooling. And then what I was going to do is talk to you about the test, kind of give you a basic idea of what to expect. And then I was just going to answer any and all questions that you have. I have that review sheet that I posted on Moodle along with the solutions. I'm happy to answer questions on that, online homework, whatever it is you need. But this is our last class meeting before the test because there is no school on Friday. It's Veterans Day. It's really important that we take that day and acknowledge the veterans, in my humble opinion. And so, again, we have class today, and then we don't have class again until Monday when we meet for the test. Okay? Does that sound like a plan? Cool. All right. One more math question for today. Or a problem that I'm going to put up for today. Okay. So hopefully you recall our Newton's law of heating and cooling. And you recall that the formula that we came up with was that the temperature of an object at time t is equal to AE to the KT plus the temperature of the surrounding air. All right. So this example is similar to the last one in section 4.6, which is why I'm actually going through and doing it. Suppose something has an initial temperature of 160 degrees Fahrenheit, and it is submerged in a tank with a temperature of 60 degrees Fahrenheit. We're given that the cooling constant is 0.6. And what we want to do is find the equation that models this cooling. So I'll give you a chance to write that down. Let me know when you're ready. Eric, did you want a copy of this review sheet? Okay. Cool. Thanks, Ross. All right. So what we want to do is we want to find this equation. Okay. Now, the thing that I always start with just like when we were playing with these last week, is the temperature of the surrounding air or surrounding whatever it is. In this case, it's submerged in a tank. So isn't the surrounding temperature 60 degrees? So I'm going to say that T of T is A e to the KT plus the surrounding temperature. So thus far, would you all agree we have this? Now, what other information are we given? Well, we're given the initial temperature. In other words, when little t equals 0, big T is equal to 160. And we're given one other thing. Notice we're given the cooling constant. When they tell you it's your cooling constant or even your heating constant, that's your value of K. But the trick here is, remember, when it's cooling, our temperature is decreasing. So this is a decreasing exponential function. And when that happens, remember, our K is negative. You'll run into this on the last question in your online homework in 4.6. So do you all agree? I can say, well, T of T is A e to the negative 0.6 T plus 60. And now what we need to do is find our value of A. Well, how are we going to find our value of A? Can't we plug in this ordered pair? Remember, our initial value when we have a horizontal asymptote is not just this number out in front. So I could say that the temperature is 160 when T is 0. So I have 160 A times E, well, negative 0.6 to the 0 power is 0. I think you'll grant me that anything raised to the 0 power is 1. Which then leaves me to solve for A by subtracting 60 from both sides. So I get my equation to be 100 e to the negative 0.6 T plus 60. Hey, what are your questions? You okay? Cool. All right, well, that completes the material for the test for section 4.6. What I'm going to do is I'm going to assign your online homework for 4.6 to be due a week from today. That'll mean it'll be due on the 16th. Okay. So the online homework for section 4.6 will be due a week from today. Your test is Monday. My hope is that you get it done sooner, but it does give you some wiggle room in terms of when you're actually going to have to get it done. All right, so what I want to say to you all is as follows. Okay, we're going to have our second of 3 tests. Our last test does not happen until finals week. But this test again is on chapters 2 and 4. And I mean, I know that this sounds like okay, sure. But if you're given, you need to know how to graph a line. And you need to know how to find the equation of a line. Okay. This goes way back to chapter 2. Additionally, you need to know that parallel lines have what? The same slope. Perpendicular lines have slopes that are anyone? Good, opposite reciprocals. So for example, if you have a line with a slope of 1/2, the slope of the line perpendicular to it is -2. Good job. Okay, if the slope of a line is -3/4, what's the slope of the line perpendicular to it? +4/3. You change the sign and you flip it. Hey, if you're given 2 ordered pairs, I'm going to ask you to find the equation of the line that passes through those 2 points. And I'm also then, with the same ordered pairs, going to ask you to find the equation of the exponential function that passes through. Okay. Y'all with me this far? All right, there was a question on your quiz from chapter 2 on the production costs. And specifically, I ask, when are they the same? You're going to want to look at that question. If you don't have your chapter 2 quiz, don't worry, I've got the solutions to it posted on our class Moodle page. All right, you're going to have one short compound interest question. A equals P1 plus R over N to the NT. And you're going to have one APY question. Not a huge amount there, but just enough. You're going to have a couple of exponential and log equations to solve. And on the test, I tell you that you can either leave them in exact form, in other words, in terms of logs, or you can, I'll say find it to like 3 decimal places or something like that. You will have a word problem similar to like section 4.6. But on the bright side, I'm already going to give you the equation. So I'll already give you the equation of the exponential function. You just get to solve a few things. With your exponential functions and the graphs, you of course need to know the effects of A, B, and if it's in terms of K, K. You had online homework questions that went after this. Remember, B is the same as e to the K. So A is our initial value. And we know, for example, when it's decaying, we know B is between 0 and 1, and K is negative. And if it's growing, we know B is greater than 1, or equivalently, K is positive. In terms of your exponential and log functions, you want to be keen on the domains and the ranges, any intercepts, and then pertaining to your exponential functions, your horizontal asymptote, and log functions, your vertical asymptote. Now, just a reminder, when we talk about our intercepts, remember, if you're given an equation of a function, tell me, how do you find your x-intercept? What do you do? Good. You set y equal to 0 and solve for x. And similarly, if you want to find your y-intercept, what do? You set x equal to 0 and solve for y. Suppose I tell you that the natural log of, who really cares? I don't know, the natural log of P is equal to Q. How would I get this out of log form and into equivalent exponential form? When you have ln, by default, what is the base of your logarithm? Okay, it's e. So the way we would change that to equivalent exponential form is e to the power of q equals p. I just don't want you to forget that. So for example, if you're solving like the natural log of P equals 7, and you want to find P, well, you would change it to equivalent exponential form, and you would say e to the 7th is P. If it was written log P equals 7, how would we change that one to equivalent exponential form? When you don't have a base written by default, what is your base? 10, good. So we would change this to 10 to the 7th equals P. All right, so that finishes up me going through the test and telling you what to focus on. Again, if you look at the chapter 2 quiz, if you've done your homework and kept up, and if you also look at this review sheet that I made you and posted on Moodle, this will certainly help prepare you. I do want to mention that the solutions to this review sheet are also on Moodle. But you know, if as you're working on it over the next several days, if you have any questions, please feel free to, of course, send me an email. But that leaves us about 28 minutes in this class for me to just answer questions or go through examples, which is really kind of a sweet thing to be able to do right before a test. So DJ Lauren will take requests if anyone has them. I'm happy to do any online homework questions. I'm happy to do anything on this review sheet that you see that you might want me to go through, but this is really your time. So please let me know. Okay. So there's no questions that are in this room at the moment. So number 3 on the review sheet. Thank you for asking a question, Alex. Any other questions? Well, we'll start there. Okay. So it's kind of hard to read on this. We have that the half-life of fermium, I almost said fermium, of fermium 253 is 3 days. If the sample initially contains 100 milligrams, we want to find a formula for the amount remaining after T days. Now remember, when we're finding these equations of these exponential functions, you could get it in either form. We certainly know how to go back and forth between the forms, right? And it's a good thing to be aware of that B is equivalent to e to the K. I wrote that to the side here. So Alex, since you're the one who asked this question, do you have a preference which way I find my equation? The left one? Okay, then I'll do the one on the right. I'm just kidding. I'm just trying to get a reaction out of anybody. Okay, well, in order to find this equation, we need to know what A and B are. I claim we're given A. What is our value of A? $100, good. We're given that it initially contains 100 milligrams. Okay, so we can start out right there. Now, what we need to then do is find our value of B. Well, what are we given? We're given the half-life. Notice they tell us to have T defined in terms of days. Aren't we given that when T is equal to 3, that we have half of our initial amount left? In other words, if we started with 100, we now have 50. All righty, I want to get B all by its lonesome. What would be my first step? We divide both sides by 100. Notice we're going to get 1/2 is equal to B cubed. But I don't want B cubed, I want B. So how do I get B to the first power? Don't I raise both sides to the 1/3 power? And if you do this computation, you're going to get B to be about, I'll just go 3 decimal places, 0.794. So this equation is 100 times 0.794 to the power of T. Alex, does that help? Now, one reminder that I have is it is not optional about bringing a calculator. You got to have a calculator for the test and you got to have a writing utensil, but you do also get an optional sheet of paper with notes. So, you know, I just want to remind you to perhaps take advantage of that if there's anything that trips you up. All right, any other requests? Nothing? Happy to do anything else on this review sheet if that would be helpful. 5B. Okay. Okay, so what we want to do is we want to solve this log equation. I wonder what that thing does. Huh. Oh, it's a light. Okay. Notice we have log base 2 of 6t plus 4 equals 5. When it's in this form, we're pretty stuck. So how do you solve this log equation? You change it to equivalent exponential form. So you take your base 2, you raise it to the 5th power, and that's equal to what you're taking the log of. Well, 2 to the 5th is 32, is 6t plus 4. In order to solve for t, what would be my first step? We'd subtract 4 from both sides. So you get 28 is 6t. And now we can divide both sides by 6. So you get 28 over 6. Or you can write that as 14/3, or you can put it in decimal form. Is that okay? Yeah, totally. I appreciate you asking a question. Anything else? I'm happy to do any and all of this. Can I do number 6? I would be happy to do number 6. Okay, so 6 is a graph analysis of exponential functions. So notice we have 3 exponential functions. This one is the AB to the X. This one is CD to the X. And this one that's decaying is P times Q to the X. Okay, so part A is which of these 3 functions has the largest growth factor? Well, 2 of these 3 are growing. So it's either going to be this dotted one or this line right here. Who's growing at a faster rate, AB to the X or CD to the X? Isn't this one steeper? The C times D to the X? So we would say C times D to the X, right? This guy's growing the fastest. Now we're given if P is equal to 3, what can we say about the value of C? What is C equal to? 3, good job, right? They have the same initial value. I'm going to ask you an additional question. What can I say about the value of A? Can't I say that A is greater than 3? Right, because it crosses my y-axis at a higher value. And finally, what can we say about the value of Q? Hint, it's decaying. So what do we know about that base? Isn't it between 0 and 1? That's a 0. Is that okay? Cool. Are there other questions? Well, thank you, Kiki. I like it when people ask me questions. Anything else on here? Number 7. Okay. So for number 7, we're given that the function is the natural log of x minus 2. I'm going to add some things to this also. Just because we're having such a ball, I'm also going to have us find the domain and range. Okay. Now, in my head, like I'm trying to think of the graph. Okay. Do you guys agree that the natural log of x minus 2 is the graph of the log of x, but which normally goes through here, but now it's shifted to the right too? Okay. You don't have to graph it. I like getting pictures in my head because it helps me to have a visual. Okay. All righty. Well, let's talk about this. First thing we were asked to find is the X-intercept. Okay. You can do that just by looking at the graph, but if you didn't graph it, this is why I went through how to find X and Y intercepts. To find the X-intercept, we set Y equal to 0. So aren't we solving 0 equals the natural log of x minus 2? Well, how do we solve this for x? We change it to equivalent exponential form. There's no base here and we have an ln. What is my base? It's e. So if I was going to change this to equivalent exponential form, wouldn't I have e to the 0 power is x minus 2? Well, anything raised to the 0 power is 1. So I'm solving 1 as x minus 2. So I get x to be 3. So my X-intercept is 3, 0. And notice that totally jived with what we had with our graph. Now, what about our Y-intercept here? Well, by my graph, it sure as heck doesn't look like it's going to go anywhere near my Y-axis. Okay. Well, a way that you can verify that there is none is by saying, well, in order to find my Y-intercept, I would set x equal to 0. But if I plug in x equals 0, that means that I'm taking the log of a negative number, which is illegal. So in this case, there is no Y-intercept. Now, if I had a plus in here and I was scooting it this way to the left, then I would have a Y-intercept. All righty. Now, with our domain, range, and asymptote, remember we had that if you have like the natural log of x minus 2, some of the things that we had when we had these shifted log functions is the domain, x minus 2, has got to be greater than 0. In other words, my domain here is x has to be greater than 2. The other thing that we saw is when we have a log function in this form, we have a vertical asymptote at that value. So in other words, you take this and you set it greater than 0. You can also simultaneously set it equal to 0. Okay, and notice that jives with my graph. And finally, I want you to know that the range of your log functions are all reals. Aren't you glad you asked number 7? Yeah, I am too, Alex. All right, cool. Number 8 now. Hey, number 8 says if g of x is equal to this shipwreck, find the x and y intercepts and the horizontal asymptote. You may or may not recall that when we have exponential functions in this form, our horizontal asymptote is y equals c. And the other thing that we saw is that our y-intercept is a plus c. Okay, so we want to find our, let's start with our x-intercept. How do you find your x-intercept? Don't you set y equal to 0? So x-intercept, we set y equal to 0. So then I'm solving 0 equals 3 times 1.04 to the x minus 5. I'm going to continue this on a scratch piece of paper. Can I solve this equation here? Totally. Okay, I want to isolate my exponential. So the first thing I'm going to do is add 5 to both sides. So I have 5 is 3 times 1.04 to the power of x. What would be my next step? Divide both sides by 3 to get our exponential isolated. And when your exponent is unknown, what do? You take the log of both sides. So the natural log of 5/3 is the natural log of 1.04 to the power of x. Which gives me the natural log of 5/3 is x times the natural log of 1.04. And so x is the natural log of 5/3 divided by the natural log of 1.04. And if you want to get a decimal approximation, that we can totally do. You're going to get it to be, I'm just going to go to the nearest whole number, 13. Okay, so that's my x-intercept. My y-intercept, if you remember that the y-intercept is a plus c, you could say 3 plus -5, and you're going to get -2. If you forget that, again, to find our y-intercept, we could just set x equal to 0 and solve for y. If I do that, I'm going to have 3 times 1.04 to the 0 power minus 5, which gives me 3 minus 5 or -2. And finally, your horizontal asymptote is whatever this value is back here. So it's the line y equals -5. Is this helping? Awesome. Awesome. Anything else you want me to go through here? Is this helping y'all online? Cool, cool. All right, well, we technically have 8 minutes. So if there's anything else you want me to do, I'm really happy to do it. If you don't have questions at this time, but you come up with questions, I am an email away, and I'm gonna be checking my email every day between now and Monday, barring like unforeseen circumstances. You okay? All right. Any other questions? All right, then. I will see you all on Monday for the test. And I hope you all have a good weekend. Take care.